Okay, so our lesson today is all about fractions and decimals on number lines. So our number lines, we know that they're gonna have a starting and a stopping point. So one thing that's really important before we start working with a number line is that we know if we're dealing with a proper fraction or an improper fraction. That will let us know what our endpoints are on this number line. So most of the fractions we're going to deal with are going to be proper. So if our fraction is 3/5, then that means we know it is less than one whole. So on our endpoints, our whole numbers are going to be 0 and 1. Now, just like if you were drawing a model, your denominator tells you how many equal pieces to break this number line into. So we know we're going to need fifths. So if I were to count, I would have 1/5, 2/5, 3/5, 4/5, or 5/5, and we know 5/5 is the same as one whole. So if we want to know where 3/5 falls on this number line, we're going to count 1, 2, 3. This would represent 3/5. Now sometimes you might get a number line and it might already be separated out for you. So let's say this one's already separated out for me. I need to figure out what it's broken into. So I need to count my pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 pieces, 10 jumps to make a whole, so I know that my denominator has to be 10. So if I wanted to know where 7/10 was, or if I wanted to say, if you see a number line like this and it says, tell me what fraction this represents. Well, I've already counted for my denominator. I've counted how many pieces there are. Now for my numerator, I need to figure out how many jumps I need to get to where I am. 1, 2, 3, 4, 5, 6, 7. So that represents 7/10. Now you'll see in your lesson today, what if it tells you to plot the number 43 hundredths? Oh my goodness gracious. If you wanted to take a number line and break it into hundredths, you'd be making tick marks for an hour. And you'd probably lose count and have to go back and recount. It would be a mess. But something that we do know about 43 hundredths, we know about hundredths, is that it's a power of 10. So it's going to be really easy for us to break this 43 hundredths down into something closer to tens. So I'm going to number bond this. And I want to know, this is a 4 in the tens place, so it represents 40 hundredths. I had 43 hundredths, I've used 40 of them, so that leaves me with 3 hundredths left. When I break my hundredths up, it's going to help make it easier for me to plot this fraction on my number line. So 40 hundredths, this is a trick that we haven't learned yet, but I'm going to show you. Or maybe we have learned it. I can make that smaller. When both numbers, both your numerator and your denominator end in a 0, you can get rid of them. So 40 hundredths is the same as 4/10. Well, that's much easier to find. 1, 2, 3. Here's 4/10. I know that's not where I'm stopping though, because I also have 3 hundredths. So we know 10 times 10 is 100, or 100 divided by 10 is 10. That means that in order to turn into hundredths, I would have to break each of these tenths into 10 little pieces. But I know I'm going to be between these two groups of tenths. So I can just break this one down. Now I can count, I need 3 of them. 1, 2, 3. So 43 hundredths would be right there. I found my tenths. I found that 40 hundredths is the same as 4 tenths. Then I just had to break between my 4 tenths and my 5 tenths down to get my 3 hundredths to make 43 hundredths. So that's how you work with them if you're working with proper fractions. Now, if you're working with improper fractions, it's a different ballgame. When we work with improper fractions, we know we're working with at least 1 whole. So if my fraction is 15/8, I know that it's improper because my numerator is larger than my denominator. So what I want to do is we're going to learn really quickly how to turn improper fractions into mixed numbers. A mixed number is something where you have a whole number and then a fraction piece. So that's what our improper fractions really are. The way we're going to do that is we're going to use the number bond. 15/8 is how many I have. I want to see how many wholes I can pull out of there. So when you make a whole, that's in your numerator is the same as your denominator. So I know that I have 8s, that's what my denominator is, that doesn't change. And I know that it takes 8/8 to make a whole. So I had 15/8, I've pulled 8/8 out. Now when I try and figure out what I have left, 15 minus 8 is 7. So I only have 7/8 left, so that's not a whole. So when I rewrite this number as a mixed number, I have 1 whole, 1 group of 8/8, and 7/8 left. That lets me know that my endpoints are not going to be 0 and 1 because this number is worth more than 1. My endpoints might be between 1 and 2, or my number line might go all the way from 0 to 2 with 1 in the middle. It's important when we're working with improper fractions to make sure we look at our whole numbers, because sometimes they'll try and trick us and they'll give us number lines that go from 0 to 1, but there's no way that our fraction could be represented there. So if I know that between each whole there are 8 pieces. So if I'm just going between 1 and 2, there's going to be 8 pieces. Or if I'm going from 0 to 2 with 1 in the middle, the whole thing can't be divided into 8 because it's 2 wholes. Each whole has to be broken into 8 little pieces. So 1 and 7/8. This is 1 whole, and then I count 1, 2, 3, 4, 5, 6, 7. That would represent this improper fraction 15/8, or 1 and 7/8, 1 whole, and 1, 2, 3, 4, 5, 6, 7. That would also represent 1 and 7/8, or 15/8. So when you work with improper fractions, just be very careful with how you put that on the number line. You might be able to do it without converting it to a mixed number. But if you need to convert it to a mixed number, remember, pull out your wholes. Sometimes you might be able to pull out more than 1. What if our mixed number was 15/6? Okay, I know it takes 6/6 to make a whole. I had 15. I used 6. Now I have 9. If I have 9/6, I can still get another whole group of 6s. 9 minus 6 is 3. 3 is what I have left now. Now I'm down to only 3/6. That's not a whole. But when I count my wholes, 1, that would be 2, and my fraction left over is 3/6. So when we're converting from improper fractions to mixed numbers, we might be able to pull out more than one whole, more than one complete group.